Yes, welcome back everyone. Today is the last day of our festival. I want to start introducing our schedule of today. We will be here with Professor Dr. Sami Gülgöz. He will be talking about reminiscence and imagination, and then there will be case studies and following mindfulness and meditation with Yasemin Paçacı. In 3:30, we will be with Burcu Ayşen Ürgen, and she will be talking about cognitive neuroscience. And then we will be with Professor Dr. Alev Erişir. She will be talking about plasticity in animal models. And lastly, we will have our panel in which we will be with Professor Dr. Ayşe Altıntaş and Professor Dr. Hakan Ürey. Today, we have a lot of seminars, so I guess we can start. Yağmur.
Okay, thank you. Hello everyone, I'm Yağmur. I'm a first year medical student in Koç University and an active member of Cohen. I'll be your moderator for this session, and our guest is Sami Gülgöz for today. Welcome, Hocam. Thank you. We're grateful for your accept our invitation and join our festival. First, I'd like to introduce him to you guys. He's an experienced professor at Koç University, and he's conducting his studies still in the university at the Laboratory for Research in Applied Memory, which is called CRAM, maybe you heard before. He completed his baccalaureate degree on psychology at Boğaziçi University and his master's degree and PhD on experimental psychology at the University of Georgia. His studies are mainly focused on human memory and autobiographical memory. He was an assistant professor at Auburn University after his PhD, and come to Koç University after that. He has been associate dean of College of Arts and Science for 2 years, and then dean of College of Science, Social Science and Humanities for 6 years. I'm also very excited to learn about reminiscence and imagination, which is our topic for today. Floor is yours, Hocam. Thank you for listening to me. I'm very excited, sorry.
Thank you, Yağmur, for this nice introduction, and thank you for inviting me to this wonderful get together. In a way, I'm especially happy to be invited to the first ever meeting, and I hope that this will continue for quite some time, and it's going to be a good tradition that you will keep on pursuing every year. Okay, so today what I plan to do is basically I'm going to be giving you basic information. I'm not going to talk much about our own research, but you know, every now and then I may mention about what we do as well. But I'm going to mostly talk about general information about memory and you know, different aspects of memory, autobiographical memory, and I will try to give you some perspective. So I think I can start by sharing my screen, and that way we will begin. Okay, so I'm assuming that you can all see my screen, my presentation, and no problem in there. So we have gotten our topic as reminiscence and imagination. And in a way, we are trying to figure out what kind of a system we have in trying to remember our past and also imagining our future. So where you consider the you know, particular days we are in, where we feel a lot of extreme uncertainty, we realize how important it can be to look at our past and try to figure out what's going to be happening in the future, because our past is not very helpful these days about figuring out what's going to be happening in the future, because we are going through days that we have not experienced before. So there's not as much use for our past experiences dealing with this situation of the COVID-19 days and the war all around us, etc. Now, we I want to start by defining memory, and my definition of memory is can be shown with a picture of the brain and hopefully a number of connections between the brain. Now, those colors in the brain are not there for making the picture more beautiful, but rather they indicate the connected areas at any given time when we are processing some information. And what happens here is that we can see that different parts of the brain are connected to each other, even though, I mean, when you look at the colors, so you can see greens being at the front part and at the rear part, etc. There are a lot of things happening at the same time. And where is memory in all this? Well, it is an emergent property. What we mean by that is that memory emerges as a result of these interactions between different systems in the brain. So we cannot really talk about having a memory residing in one particular neuron, but rather what we say is that the memory itself is actually a function or a result of, an outcome of a number of communications between different parts of the brain. So the questions have been, I mean, the age-old questions have been, what is memory and what is it for? Okay. These two questions may seem quite ordinary, but at the same time, it gives us a particular perspective. And these are two different perspectives in one sense. When you say what is memory, we're actually searching for a structural property. We want to understand the structure of memory system. What kind of a structure does it have? And you know, what happens in different parts of the memory systems. But when you change your question to what is it for, now we're beginning to focus on a functional system. And in a way, when we have a functional perspective, we're basically saying, okay, we have a memory, but this memory must have evolved throughout the evolutionary timeline for some purpose. I mean, there must be some purpose that this memory system made human beings more likely to survive and reproduce. There must be some benefit from all this memory system. So when I say, what is it for? When I ask that question, I ask it in the sense that what kind of mechanisms or what kind of benefits does it provide to human beings for better survival, for better adaptation to the environment? And some of these will be obvious to all of you. I mean, it's good for memory to tell us about where we can find food, think about archaic ancestors, where, it's important to remember where food was available and where the food was hidden, stored, etc. So those are the kind of things for as a very simple example of what memory is for. And we know that other animals than humans also use their memories for those purposes as well. Now, when we look at memory stages, or at least in the past, we used to talk about memory stages, and we used to talk about encoding, storage, and retrieval. So in a way, we would say, okay, first we have to encode information, then we have to store it, and then retrieve it. What that means is that, well, we have to look at our environment and get the information. And then when we got the information, we have to keep that information in some form in our mind. And then whenever it's necessary, we need to retrieve those. So these obviously present their own questions. I mean, when you look at this memory system as these three stages, they necessarily present their own problems. I mean, when you say encoding, well, how do you encode information in your memory system? How do you really put an information into your mind? When you say storage, well, where is information stored, in what form, why do we store some things and why not other things, etc. And then retrieval, again, brings its own problems such that, how is it that sometimes I know that I know something, but I cannot remember it, I cannot retrieve it. Somebody asks me a question, I say, well, I know that, but I can't retrieve it right now. Or sometimes, how can we find that information among lots and lots of information that we have in our mind? We just go ahead and pick that information and find it and use it. So these are major questions that were asked. Recently, we began to talk about encoding, consolidation, and retrieval rather than storage, because we began to talk about more of a process where once we encode some information from the external world, let's say, or internal world, that is, I can be encoding information that I sense with my sensory system, but at the same time, I may encode some thought that I have had, right? I mean, I can think of something and I say, okay, let me remember this thought. I'm going to be using this. So we have to encode this information, and there may be many factors in encoding, such as I may decide to encode some information. I tell to myself, hey, I have to remember this. I work on it. I try to memorize it or whatever. Then the issue of attention, how much attention am I paying to this system? And there are other factors like novelty. I mean, if something is novel, something that I never heard, something very interesting to me, I happen to encode that information more easily. But when you talk about storage, we are not, in the past, we used to talk about storage as a passive system. That is, we took the information to the encoding system and stored it somewhere and kept it there. Now, we don't really consider storage as a passive system anyway, anymore. What we do is that we consider that there is some form of consolidation, which goes through stages. Which goes through stages such as first at the synaptic level, that is at the neuron level, they get to be consolidated, they get to be attached to each other, and there's a group of neurons working together to keep that memory. And then there's system consolidation, which means that we're putting all that information to different areas of the brain. And then there is the idea that we activate these consolidated memories every now and then. What that means is that we actually create some kind of a thought which allows us to think about what we already have. And retrieval is part of it. So what happens in retrieval is that we focus at a particular stage in our lifetime, or we can focus on a particular set of information, and we try to retrieve information on that basis. But the problem is, or not the problem, but actually it's not a problem, in the sense that it creates trouble for our lives, but it's a problem for us to understand as scientists. The problem is we are discovering that every time we retrieve information, we are actually reprocessing that information. It may be that another set of encoding. So every time we think about the past memory is no longer what it used to be in the system, but rather it becomes a newly processed and new information. And therefore, we encode that new information if there have been certain changes added to that. So it is a much more dynamic system than the system we taught earlier. So the earlier models of memory were in this form. This is a model, standard model, or Atkinson-Shiffrin model, whatever you want to call it. But what happens is that the information comes into the sensory system, and from the sensory system, for a very brief duration, for a couple of seconds or so, it's kept in the sensory memory and then lost. and then if it is attended to, it is sent to short-term memory. In short-term memory, or what we call working memory right now, we rehearse that information, we repeat that information to ourselves. And if we transfer this information to long-term memory, we keep it for a long time, otherwise we lose it. And every time we want to remember some information, we retrieve it from our long-term memory. And this is a typical way the memory was characterized for a long time. But when we are talking about encoding, and let me start by talking about encoding, when we talk about encoding, we really should not be thinking of our memory as a recording device like, our smartphones who are, recording videos or anything like that, because there are different types of information that we attend to. We actually think about what we are seeing, and we have to remember that whenever we are encoding or perceiving an event, we are actually perceiving that particular event with the background knowledge, with the prior knowledge that we have. We are activating all of that, and with our biases and prejudices and emotions, etc. I mean, all of them are at work at that particular moment when we are trying to encode the information. So, we also know that certain types of processing have advantages over others. For example, semantic judgment. If I give people, let's say, a list of words, and to one group I will ask them how pleasant the word is. They have to rate how pleasant it is. A second group have to rate whether it rhymes with a particular word. Does it rhyme with the word strong, for example? And the third group has to judge whether that particular word looks pretty when it is typed, okay? So what happens is that we see that the memory for semantic judgment, that is those people who thought about the meaning of the word, they remember later many more words than the other groups, and the rhyming group remembers better than the visual group. So what that means, in a sense, is that these people didn't know that they were going to be tested later on. So what they were doing was just judgment, and semantic judgments, the judgments based on meaning, was allowing people to remember better. So what does that tell us is that there seems to be some structural components to our memory system which allow certain types of memories or certain types of information to be stored in our memory system better. So encoding by itself is not a passive system. It is helped by other components. Now, when we talk about semantic judgment, what that means is that when we are making a judgment about a word or a sentence or whatever it is, it means that we are activating everything we know about that word. So we are using our prior knowledge, our existing knowledge. So what we can tell from this is that encoding is much better when we are making a connection with already existing knowledge, okay? So we can encode information much better if we are, in a way, making some meaning out of it by making a connection with what we have learned in the past, what is already in our memory system. The second, in the second line here, there's rhyme. Rhyme is an important component, which we cannot explain very well why, but this is one reason why, for example, a poem is much more difficult to remember than a song. You can memorize a song, you can remember a song and the lyrics of the song much more easier than you can for a poem, for example, but you can consider the lyrics of the songs like to be just like a poem, and sometimes they are poetry, right? But what happens is that we seem to be remembering songs much better if we, so, you know, if you want to remember something, turn it into a song, you will be able to remember it much easily. Let me, at this point, share a video, but for a moment, I have to stop share and start again because I didn't, okay, I didn't optimize it for video. So let me do that. Okay. Now, I'm sure you can see my screen again, right?
Yes, we can.
This is a video. Please watch carefully.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
That's right, madam.
It's just a matter of observation. The real question is, how observant were you?
And action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Okay. Now, I'm not sure whether you were able to detect any of the changes while you were watching the video. Of course, this was a, you know, wonderful, you know, public message for people becoming aware of the cyclists. And yes, we should be aware of the cyclists. But the idea here is that, you know, when we are watching and when we are observing something, we may be extremely unaware of what is happening. And if you realize the man who was on the floor became a completely different man, the flowers changed, you know, so, I mean, there are 21 changes throughout the whole video, the short segment that we observe. There have been 21 changes in the whole video. And so far, I have not seen many people who were aware of those changes while they were watching the video. So as you can see, when we say encoding, we're not really talking about being able to detect everything in our environment. So we are basically focusing on certain things and ignoring everything else. Many of the details about our environment is basically beyond our ability to perceive. So what we are doing in encoding is simply selecting information from our environment, attending to it, and attending to it on the basis of what we have in terms of our preconceptions, our expectations, our knowledge, etc. So we are looking at this kind of a scene with already existing thoughts, already existing background. And so when you ask the question, well, when two people watch the same event, why don't they remember the same exact event? Well, to begin with, they're not encoding the same event, okay? To begin with, they're not looking at the same things. So for that reason, we cannot expect two people to have the same account of a particular event that they have been exposed to. So as a result, what we can see here is that encoding is a very active and dynamic process. It has a lot to do with what is coming from the external world, what's happening inside our minds, what we already know, what we have experienced in the past, similar events or movies or whatever we have seen. All of these are coming together to create a particular encoding situation. So it is very difficult to explain encoding with a simple, clear variable or a clear word that can explain it all. And there's one thing we must really be careful. For example, I can see that many of you are students. One thing about student that I have to say is that encoding is a process that we need to be very careful in the sense that, for example, when we study for the exams, I have had that experience many times. I studied it really well. I read the book and everything, but I couldn't remember it during the exam. Well, what's happening is that, yes, I may have read something, but reading alone will not be encoding. That is, we have to have a very clear encoding system where I actually use all my previous knowledge to make meaning out of what I'm trying to learn, so that I can maintain that information for a longer duration. So we're working, the first point that we talk about is the working memory system. And when we talk about the working memory, we're saying that, okay, at any given time, at this very moment, we're thinking about certain things. And the things that we're thinking about is actually what the contents of our working memory is. That is, working memory is at any given time, the components or the contents of what we are doing right now. And as we all know, and I hope we know, there's a capacity limitation. That is, we cannot hold in our working memory beyond a number of items. So when for example, if I ask you to keep in your mind a number of digits that I tell you one after another, such as, keep this in mind, I'll ask you to tell me these numbers in the same order that I tell you, okay? Keep them in mind. Okay, ready? I'm starting now. Okay, 5, 3, 9, 4, 7, 6, 3, 8, 1, 0, 7, 4, 6. Okay, at one point you said, okay, enough, I can't have one more in there, right? I mean, it's just, it's impossible to include one more number in there because it's not taking. There's a limit. So I wanted to make you to feel that limitation of the capacity. That is, we cannot really feel, we cannot really take in or keep in mind more than a certain amount of information. And that's very critical because, and you already know that actually. Where do you know that? Well, before the exam, somebody tells you something that you should know for the exam, and you keep that in your mind. You keep on repeating it to yourself. You don't want to talk to anyone because in case you talk to anyone, you would feel that you can forget that information. So therefore, you prevent anybody from talking to you. What are you doing at this point? You are aware that there's a capacity limitation of your working memory, and therefore you want to keep other people's information out of your working memory and reserve your working memory capacity for that information that you need in the exam. And when the exam paper comes in, you write to the corner of the exam that particular information, and now you can think about other things. Because what you have done is you have offloaded your working memory to the paper. And this is a concept that we use, offloading. That is, we offload information, whether it is on paper, on our computer, on our smartphone, or whatever. We offload information so that we don't have to keep them in mind, okay? And that's a huge help, obviously. Okay, and I suppose writing has all began with the need to offload information. I mean, the people couldn't keep a lot of information in their memory system. They felt the need to offload, so they began putting marks on whatever they wanted to put marks on. First, it can be the walls, where they counted certain things. Anyway, so what we do is that we try to measure capacity limitation by using simple and complex span tasks. The kind of task I just showed you, reading digits of numbers and then asking people to tell them back, is basically a simple span task. And complex ones are more difficult, a little bit more complicated, in the sense that, I say, like, okay, I'm going to give you a number of sentences, and I want you to keep in mind the last, no, I want you to repeat those sentences, but keep in mind the last word of that sentence. So I say, okay, now I'm talking about working memory. So you have to repeat to me, now I'm talking to you about working memory, and then keep memory in mind. Then I give you a second sentence. When I give you the second sentence, I'm going to the school today. You say, I'm going to the school today, and then you have to say memory today. Okay, so you will have to keep the last word. So that becomes a more complex task because it makes, it gives more load to your working memory system. There's obviously temporal constraints. That is, there's a certain amount of time that if you don't rehearse any information, if you don't repeat the information to yourself, the information will be lost from the working memory. Somebody says something, you say, oh, okay, and then wait, I didn't really encode that information. Can you tell that to me again? What did you do? You didn't repeat that to yourself, and it was gone. Chunking is a method that we use, again, inadvertently sometimes, and sometimes memory masters use that. That is, we put information together. So instead of, if I give you, for example, if I give you a set of numbers like 6, 7, 3, 4, etc., and I ask you to repeat them after me, instead of trying to remember them as 6, 7, 3, 4, you try to chunk them or make bigger units by combining them and making it 67, 34, etc. And that will allow you to have a bigger capacity in your working memory. One of the questions in the literature about working memory has been whether you lose information from the working memory because of decay or interference. What we mean by interference is that new information comes in, and when new information comes in, because there's not much space in your working memory, you lose the old information. So while you were thinking about something, somebody asked you a question and you forget what you were thinking about, okay? So this is interference. This is where new information is not allowing you to remember the old one because there's not as much space. And some people say that the information in working memory is lost because of time. Now, this is a difficult question to answer. The reason for that is, well, how can you tell the difference? Because working memory is never empty. That is, there's always interference in working memory. There's always information, whether it's coming from the outside, whether it's internal thoughts, there's always something in the working memory. I mean, you cannot do like, okay, let's not think about anything. Are you not able to think about anything? Impossible, right? When you're saying to yourself, okay, I'm not going to think about anything. What you're thinking about is that you should not be thinking about anything. So that is impossible. You are always thinking about something. So working memory is always full. I mean, not full to the whole capacity, but it is always working. And for that reason, it's very difficult to distinguish between decay and interference, because we cannot say that information is decaying by time alone, because there's always interference from other information. One of the things that we know about this kind of working memory is the fact that what happens is that there's primacy and recency effect. That is, when we give a person a list of words to study, let's say book, table, cup, phone, whatever. Book, table, cup, phone, paper. Book, table, cup, phone, paper. What happens is that you see the word book and you begin to yourself to repeat to yourself, book, 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 book. And then I present to you table, you say book, 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 table, book, table, book, table, book, table. And then I present to you cup, you say book, table, cup, book, table, cup, book, table, cup. And then I give phone, you say book, table, cup, phone, book, table, cup, phone, etc. So what's happening is that book begins, book becomes the most repeated word among the list. So we assume that because of that, we have a primacy effect. That is, those words at the beginning of a list tend to be remembered much better. And we see that in research. And why is this happening? Well, because those words are repeated much more than the words in the middle or in the end of the list. But still, there's a recency effect. The words at the end of the list are remembered better too. And that recency effect is, from what we understand, is those words that are still in working memory, that have not been lost in working memory. And what we see most often is that when people report those words, when you want them to recall them, they begin with the last words. Okay, they begin with reporting the last words. Why is that? Because that's still in working memory. They're still capturing that information from their working memory. Now, talking about working memory, I wanted to show you this video with my favorite animals.
The numbers 1 to 9 are randomly scattered across a touchscreen. The chimp looks at them for as long as is needed to memorize the layout. Then, as soon as 1 is touched, the other numbers are hidden and must now be remembered. We volunteered Chris, the director of this program, to demonstrate this test. He's a college graduate and a crossword addict, but how good is his working memory? When Chris reckons he has memorized the layout, he touches 1. When the others are hidden, he must try to recall 2 to 9 in ascending order.
It takes me ages to remember where they're all placed, and then I think I've got it. It's really very, very difficult.
In 30 attempts, Chris only once reached 9 without making a mistake.
As soon as they're blanked over, it's like my mind's been blanked over as well.
When Ayumu sat the same test, he correctly remembered the numbers almost 90% of the time.
Ayumu gets it right almost every time, and I've got it right once.
Chris fears he's let his species down. But even when the PRI played Ayumu against their best human students who were given regular practice sessions, Ayumu still beat all humans. Other chimps at the PRI have also sat the exams. Among these apes, computer skills are as normal as the ability to swing from the trees. Though none of his rivals beat Ayumu, a few came close, and average chimp results turned out to be higher than amongst humans. So, does that efficient working memory mean chimps are cleverer than humans?
Okay, so, this is an astounding observation that, when we are really flabbergasted when we see such performance by chimpanzees, because, numbers, chimpanzees know numbers, And they can, I mean, beyond learning numbers, they can learn the order of numbers, and they can see them on the screen and follow them and perform much better than human beings on that. So Ayumi obviously is a highly skilled chimpanzees, but the idea is that any chimpanzee is performing better than the average human being. So as you can see, or any average in Kyoto, this is the Kyoto lab, Kyoto University lab in Japan, but you can see that they are performing better than humans. So what does that tell us? You know, the reason I'm showing this particular video every time, I mean, I have similar videos of Ayumi. I am really fascinated by what these chimpanzees can do. The idea here is that, well, number one, we have to look at, you know, I'm trying to go back to the very beginning when I said, okay, what is memory for? Okay, now we can't really tell that Ayumi and human beings and chimpanzees, and you know, we have evolved a particular memory skill so that we can actually count numbers on the screen. That's not a obvious you know, reason that we can actually claim. But what we have to think about is that when we think about evolution of a particular skill, we have to think about what can this be, this skill can be an extension of. Because when we think about our memory systems, like working memory, we shouldn't be thinking about what we do with this skill now. We have to think about what may have helped in our evolution. What about this memory system may have helped in our evolution, so that now we have this basic memory system, but we are utilizing it for many different purposes. Okay, we're using it for a completely different purpose now. So it may, I mean, obviously, this is not a memory system. Working memory is not a memory system that has been developed or that has evolved as a you know, response to the need to be able to follow numbers. But there have been other needs in the evolutionary timeline that has made this particular skill important for survival. That is, our ability to keep in our working memory certain type of information. For example, being able to track predators, being able to track sources of food, etc. Those are important. I mean, we see similar result with birds as well. For example, some birds keep track of where they have cached food, where they have hidden food, and they can find food that they have cached very easily. But it's not only that, but they can also remember where they cached what kind of food, so that they would first go to those places where the food, the type of food that they cached, is likely to be spoiled. So if they first go to those kind of food that would be likely to spoil, and then they go to the other kind of food that is likely to, you know, not spoil, that is likely to be good for a longer amount of time. So those are the skills that have been observed in many animals. Alan Badley is a famous psychologist who did a lot of research on working memory, talks about a particular type of working memory system that is composed of 4 units: these phonological loop, episodic buffer, visual spatial sketchpad, and central executive. Simply those areas that are, that are keeping information in working memory. What does it do? Well, phonological loop keeps, you know, language information. Episodic buffer keeps up with what is happening at any given time. Visual spatial sketchpad is necessary for navigation, where am I going, which way should I follow, etc. And there's a central executive that controls it all. Another approach to working memory is Cohen's approach, and Cohen says that working memory is actually an activated part of long-term memory. So we have a long-term memory, but we activate a certain groups of connections in the working memory, and as a result of that, I can have a awareness of some kind of memory. And I think personally, I'm more in favor of this model in the sense that it seems like, whatever is activated in my mind is actually the working memory at any given time. Now, after an information is encoded, one of the things that happens is that it needs to be first consolidated. Now, as I said before, there are two types of consolidation. One of them is called synaptic consolidation. The other is called the system consolidation. Now, synaptic consolidation is something that happens in the hippocampus, a particular area in the brain, in the medial temporal lobe. Hippocampus is, in Greek, it means seahorse, because hippocampus is likened in shape to a seahorse, and hippo, obviously horse. The hippo comes from, you may know the word hippo because, hippodrome, for example, is also a word where horses race, etc. Okay, so anyway, what happens is in the hippocampus is that a number of neurons make a connection, and this connection is strengthened. And when it's strengthened, it becomes a memory trace, or what some people call an engram. And as a result, this memory trace is occurring within the hippocampus. Now, the problem is that hippocampus is limited and cannot hold a lot of information. So therefore, for a long term, that is in terms of making this a remote memory, that is being able to remember it for a long time, it just like we offload our memory system to paper and computer and smartphones, the hippocampus offloads that information to different areas of the cortex. And so, for example, some of the visual information in that memory goes to visual cortex, auditory information goes to auditory cortex, etc. So the information begins to be spread at different areas of the brain. And as a result, the consolidation is now much wider in the cortex. And the hippocampus does not really have much of a connection anymore, and the connections are not there unless they are needed to be connected again. And the important thing is that consolidation has, at first, it's very critical in being able to encode and maintain information for a long time. And the hippocampus is primarily responsible from this. And at the initial stage, what happens is that the hippocampus makes a initial processing of that, but in time, especially during times of less activity by the person, by less mental activity, such as sleep, the system consolidation happens. The system consolidation requires, for that reason, a quality of sleep. So that's why sleep is extremely important for human memory. Okay, now we talk about implicit, explicit memories and semantic episodic memories, but we can talk about what is your favorite musical band, for example. What is your favorite musical band? I ask you that question, you try to find your favorite musical band, or what's your mother's name, what's the capital city of China, or which store do you generally buy your groceries from? You may have a store that you prefer to go, and every time you need groceries, you go to that store. So when I ask you that, you try to remember the name of that store. And what was the last birthday party you went to? Did you buy a gift for that birthday, etc.? These are explicit memories. You know about them, you can retrieve them, etc. How do you retrieve them? Well, you have retrieval cues, that allows us to remember certain things. We have the idea of encoding specificity. So this is a very difficult word for me. Encoding specificity principle, or state-dependent learning, which means that we may be learning under certain context, and it is easier for us to remember the same thing in the same context. Although, just like that cartoon shows, this is not true for being drunk. Under alcohol, you don't remember things much better if you are under the influence of alcohol again. So how does forgetting occur? Well, there's interference that we talked about before. There's decay. There's motivated forgetting. There's retrieval failure. We cannot get them. But the idea of implicit memory is quite important from my perspective, and that is the idea that most of our learning is not intentional. As you can see, we talk about incidental learning. That is, we learn stuff without being aware of it. And this emerges in many different ways. One of the ways is cryptomnesia. That is, for example, the inadvertent plagiarism when one song remembers, when one song resembles another song that has been composed years and years ago. The composer of the new song doesn't remember having heard it, but inadvertently learned it. These are, in the case, for example, if I ask you to complete these words, what would you say, for example? What are these two words? Okay, now I was trying to get you to, I was trying to prime you to get you to answer to me store and band, because I repeated the word store many times, and I asked you about your favorite band and everything. You may not have, but what happens is that generally people remember the word or complete the words as store and band many more times than they do with the other ones, because that they heard about the other ones before, even though they weren't really thinking about store and band before. And that is implicit learning. We learn implicitly. Okay, I know I'm running out of time, so I should rush here a little bit. Autobiographical memory is about one's own life and what we think about. And we have basically the feeling of remembering the event very clearly. We think it's a true record of it. And we have this feeling that we were there at the time. It's a consciousness. And I will skip these models, and I'm going to talk about reminiscence pump a little bit. When you work with people who are older than 45 or so, generally what you see is that they remember, the events that they remember come from mostly between ages 15 to 30, or sometimes 10 to 30. And it seems like there's a tendency for that. I mean, if everything was just forgetting, you would get the red line, but we're getting the yellow line for some reason. And there may be a few different things happening. First of all, number one, most of the events we experience between the ages 15 to 30 are new events that we have not experienced before, and they are entertaining or exciting to us, therefore they're encoded better. Another thing is that between 15 and 30, our cognitive abilities are at their peak, therefore we may be encoding information. Another is that we're experiencing most of the events that form our identity at the time, so that may be that. And the other two are basically, we may be using the general life scripts or our life stories to retrieve this information. So those are the events that make us our life stories much more. I will pass my twin study, and I will also mention about imagining. Now, we use the already existing information to imagine the future. And this is very critical because we see that most of our imagination relies on what we know about the past. And this is not only evidence from, experimental research, but evidence from the imaging, which is coming from, in this particular case, functional magnetic resonance imaging. These kind of information also points to the fact that the areas of the brain that are active during thinking about the past and thinking about the future are pretty much very common. They have a lot of commonality. So if you know a little bit about these images, you would know that the more a particular area approaches yellow, the more active they are. So it seems like the same areas are quite active in remembering the past and imagining the future. So I liken the memory system to this particular event where the picture on the left is the library at Ephesus, reconstructed on the basis of archaeological knowledge. So this is something we do, we reconstruct information. But moreover, the one on the right is an artistic reconstruction of what is on the left, which the painter decided what it should be looking like. And as a result, you can see that the memory is precisely what we do when we have some raw materials and we reconstruct our past. I'm not going to talk about false memory. I don't have time. Maybe I should deal with questions at this point. Thank you for listening. And wow, okay. Sorry about taking too much time. More time than you allowed me.
Thank you for this excellent seminar. It was really inspiring and enjoyable, I think. Yes, we have some questions and I can ask them. We have some questions from the participants now. They asked some 6 questions, I think. The first one is, what type of place does post-memories hold in this encoding consolidation retrieval process? Is it what our minds create without encoding, or that encoding happens but without real life basis?
Could you repeat the question? I'm sorry, I had a difficulty understanding it.
What type of place does post-memories hold in this encoding consolidation retrieval process? Is it what our minds create without encoding, or that encoding happens but without real life basis?
Confusing, I think. Yeah, what happens is that in the encoding process, there are many factors that are getting involved. That is, we're not only encoding the external events, but we're also encoding what we are thinking about or how we are interpreting those events. And across time, our knowledge changes. And we know more about the world, we know more about the life, or we change our perspective. It doesn't have to be more, but it can be different. We may know differently about the world. And as a result of that, our encoding patterns may change on the basis of what we experience and what we already know. And so in addition to that, the particular context that we are in, that is, our attention may be drawn to something by external forces, and therefore our encoding may change on the basis of that. So I'm not sure if I'm really answering what you're asking, but the patterns of encoding are not that clearly stable to really give a pattern about encoding, but rather they are quite, let's say, vulnerable to different types of influences at the time of encoding. And when we retrieve an information and encode it again, the same kind of influences exist as well. Okay, that is the external and internal influences. Yeah.
Okay, another question is that how can we improve our long-term memory, and is our brain is capable to remember all the information without forgetting and transforming into the short-term memory?
Well, now long-term memory, as far as we can say, there seems to be no limit to how much information we can hold in long-term memory. Okay, that is, at no point in time, for example, a very old person, for example, will not say, okay, stop, my brain is full. At this point, I'm not going to be learning any information. This is not happening. Okay, so long-term memory seems to be a limitless container of information. But obviously, this is not possible if you consider all the things that one has to remember. So there must be some way of pruning. What I mean by pruning is removing some information in time that we have not used for a long time, and involve these neuron systems and the synaptic connections for other information that needs to be coded. So the idea here is, well, okay, what would happen in the working memory to make information more likely to be in the long-term memory? And the critical issue there is that it seems like the more connected a particular type of information is to already existing knowledge, the better it will be retained. And after that, the more it is rehearsed, the more likely it is retained. So what are we talking about? If you have a new information coming in, okay, what you need to do is that you need to take that information from your working memory and put it in your long-term memory, right? What you need to do is use that information in many different contexts, connect it to your own life, connect it to something you learned before, connect it to some book you have read, etc., etc. And that information would be connected to many different types of information in the long-term memory, which will keep these connections, which will make it much more connected in the brain system. Now, I didn't have time. I'm sorry, I really didn't control my time much, or I tried to talk too much about certain things. But the idea there is that if you have more connections in the brain, involve some information in a well-connected system, okay, a system of knowledge, if you will consider that. All these different types of information about the same thing being connected to each other, that information will be maintained for a long time. And also, especially if every now and then you review that information to yourself and say, okay, sometimes we review inadvertently. That is, we do not try to review, but, the question comes up. For example, I can talk about my knowledge about statistics. Certain statistical procedures are a part of my daily research. I use it all the time. Therefore, I review those statistical procedures in my mind, and I don't forget those. But sometimes, every now and then, I need to refer to some statistical procedure that the last time I talked about, I was in graduate school, which was the last century. So at that point, I may have to go back to books and rekindle that knowledge that I had, or sometimes even relearn the whole thing because I won't remember much about it. Okay, so because I have not activated that information in a long time, that information that gets lost. So it's use it or lose it kind of situation.
Okay. Thank you, Hocam. Actually, we have still time for the next until the next session. If you have time, we can take some questions too.
Okay.
Okay. Thank you, Hocam. And again, the next question is, actually, you have mentioned before a bit, but he or she asked that, is synthesia a type of unusual way of data consolidation, such as smelling information is linked to hearing information?
Come again, I'm sorry.
Okay, I'm a bit faster, sorry. Is synthesia a type of unusual way of data consolidation, such as smelling information is linked to hearing information?
Mm-hmm. The idea here is that the kind of consolidation processes at this point, or reconsolidation processes, are not that clear to us. Okay, I mean, what do we know? Well, we know that, for example, many of the consolidation processes require sleep. Okay, we know that. We know that it requires some break from actually thinking about certain things. But in terms of whether one modality of information, or another type of information would be really mixing up along the way, or in some way it is confusing our memory system. I'm not really sure, because I'm really not informed sufficiently about what is really happening there. Because in this case, what's happening is it's as if one modality of information, one sensory modality of information, is getting confused with another modality of information. So I'm not really sure how the memory systems are interacting with that. Now, I cannot think any perceptual system that is not relying on the memory system to benefit from that. But the question is, at what point during the perception the memory process gets involved? I mean, in the past, we used to think that, for example, the retina was just taking in the information and transmitting them to the brain. But now we're not saying that. We're saying that retina does a lot of processing of information. The cells in the retina are doing a lot of information processing before that information goes to the brain. So I'm not really quite sure about the dynamics that are happening in cases like that, to be honest.
Okay, thank you very much. And
I mean, I generally try to refrain from speculating on things that I really don't know much about.
Okay, John, thank you very much, really. And the other question is, I'm curious about how words are retained in the long-term memory in the case of second language, like our house and ev clustered together, and recalling one of them is quicker after seeing the other word, or would it be easier to recall ev with our other Turkish words related to ev, like oda or something like that?
Yeah. Now, this is a very debatable issue. The debate emerges from the fact that when you talk about the second language, are you really talking about a separate storage system, a set of connections that are completely different from one language, which means, do we have a network of, a language network for one language that is specific and different from the other language, or is it a common source that they all rely on? And this is a difficult question for that reason. And the idea is, a lot of people have shown that being able to use vocabulary in a second language is generally associated with the ability to actually use that particular word in the context in the language, rather than thinking about it in terms of the translation of one word in another language that you know very well. Okay. Now this points to a separate store hypothesis, the idea that we have a separate group of connections for one language. Now, what I would speculate, again, this is speculation because I wouldn't really have as much knowledge about it, and I don't think the literature provides us enough information about it. But if I should speculate, I would say that probably conceptually, these are all connected to one idea. That is, when we say room and oda, we're basically thinking about the same thing. But, I mean, for example, I have lived in the US for a long time, and I have lived in Turkey for a long time. And it doesn't happen that when I say room, I think about the room I lived in the US. And when I say oda, I think about the room I lived in Turkey. It doesn't happen, okay? That's not the case. So it seems like conceptually they are the same kind of a network, but also because the words in one language are associated more with the word in the same language as opposed to the other language, because we use these words in the same language together. They form a better network or closer network of words or concepts, which I also connected to the conceptual database, I would imagine. I would say that words would be remembered in context much better, in the context of its own language, much better than when they are used as a, oda means room or room means other kind of translation system. I don't know if it's helpful, but that's what I think.
I think it's very helpful. Thank you. How can we separate memories in terms of real or imaginative ways? I would like to learn this because so many mental illnesses represent with hallucination. Yoshi says.
Yeah. The question is, there is not that many properties of events that, or memories that we can use to distinguish between real and imagined, or real and dreamt, for example. Actually, that is a very million-dollar question. And I say $1 million because it is true. I mean, if you wrote a grant and going to find an answer to that question, somebody will pay you $1 million. The idea here is that, I will reverse that question. And I will say, how do we really know, when you, for example, how do you know that a particular event is something you dreamt of rather than something you experienced? Okay, that is, this may be from philosophy to, neurology. This may involve several stages of studies, but it's a very difficult question to answer. That is, yes, I know that I dreamt about it and not actually experienced it, but the question is, how do I know it? Okay. Now, in terms of, if you ask in the question, I mean, and we don't have an answer to that question. If you're asking the question, well, can you distinguish it on the basis of memory reports? That is, if somebody told me a memory, was there a way that I read this account or I heard this account and I could actually point out to certain details or certain characteristics of these that will make me able to separate whether this person is making that up or actually experienced it? My answer is unfortunately no. Okay, especially if you have a pathological case where they may have this difficulty distinguishing between what is real and what is not real. This is even more difficult. Okay, I always give the example of this. I used to wake up and the first thing I did was look at my mail, and then I would go to shower. And sometimes, somebody wrote me an email, and I went into the shower, and in the shower I'm thinking, what kind of an answer I should write in a very detailed manner. And, you know, later I remember this as if I had already responded to that email, even though I hadn't. Okay, so this is a possible thing, and I have, you know, I have in my mind a very vivid memory of answering, and I know the words, exact words that I typed in the email, but the email is not there. So there's proof that it's not there. Okay, so it's very difficult, really.
Okay, thank you very much.
This is wonderful. I'm answering all the questions we don't know. Okay.
Okay, thank you very much, Hocam. I personally enjoyed very much and inspired from you. I want to make double major with psychology. Thank you for your speech and knowledge and kindness. And thank you very much.
Thank you very much for listening and spending the time with me. Thank you for inviting me as well. Have a good time.
Hocam, before finishing, can we take a picture together?
Sure. There's no together here, but yeah.
Yeah. So our participants, can you open your cameras if you want? I'm waiting for a minute. Okay, now I'm taking it. 1, 2, 3. Thanks a lot, Hocam.
Okay, take care. Have a good Sunday.
Have a good day.
Bye-bye.
Okay, guys, our next session will start at 1:30, and it will be about case studies, and cases will be different than those of yesterday's. See you at 1:30.